Okay, let's look at this question from question 4, November 2018 on the gas laws. There's a graph in this question. I can't draw the graph, but I've put the graph from the memo in here so we can have a look at it. Here are my formulae and my things from the data sheet that we might need to use. So let's go ahead and have a look at the question here. So, a certain amount of gas is sealed in a container of which the volume can change. The relationship between the pressure and volume of the gas at 20 degrees C is investigated. The results of the experiment are given in the table below. Name the gas law that is represented by the results of the experiment. Okay, we've got a pressure and volume with a constant temperature. Whose law is pressure and volume? It is Boyle's law. Boyle's law is the law that looks at this. Write down a hypothesis for this investigation. Okay, so now in order to write a hypothesis, we need a dependent variable and an independent variable, and we need, as it is a hypothesis and not a question, we need to predict what's going to happen. In a hypothesis, you make a prediction that your experiment will either prove or disprove. So what are we changing? Okay, we are changing the pressure and we are measuring the volume. So our hypothesis must state that at a constant temperature, this is my fixed variable, my controlled variable, at a constant temperature, increasing the pressure of a gas will decrease its volume. And then you can write here, the pressure is inversely proportional to the volume. So when you do this, always check that you have both variables. If there's a controlled variable, try and mention the controlled variable as well, but make sure that you state what you are doing. Okay, we are not fiddling with the volume, we're fiddling with the pressure. So you have to say increasing the pressure of the gas will decrease its volume. We've actually made a prediction here because this is a hypothesis. Now it says draw a graph of volume versus pressure on the answer sheet attached. So the answer sheet has actually got your axes labeled. So remember, the independent is supposed to go on the x-axis. So the graph sheet should be labeled like that. If it's not, make sure you put the independent on the x-axis. So what you must do is take a look at all of your readings here. The lowest is 70, the highest is 260, so your graph must accommodate that. And your lowest here is 47 and your highest is 174. So an axis going to a little bit above this, like 300 and 200 on the volume side, should work out well. So let's go down and have a look here. This is what the graph looks like. Okay, a maximum volume of 200, and you can see it exactly fits on here using 2 blocks for 50 degrees. And then here you've got a couple of blocks left over, but you haven't ended up with a little graph over here. You've ended up with a graph basically filling the page, which is what you want. So if you were so silly as to not make a scale and just put the values on the axis here on every block, please never ever do that in my class. You would only get 1 mark. Your marks are 1 mark for the correct scale, 1 mark for 5 of your points plotted correctly, and 1 mark for joining them with the curve. So that's quite a lot of work for 3 marks. But anyway, that's what they chose to do. Now it says calculate the volume of the gas at 300 kilopascals. So we don't have 300 kilopascals in here, but we've got plenty of pressure and volume readings. So we can use P1 V1 over T1 equals P2 V2 over T2, but we know that the temperature is not changing, this temperature over here, it's not changing. So then we end up with P1 V1 equals P2 V2. Okay, so where will we get our values from? We know that our P2 is going to be this, and then the P1 V1 we can get anywhere from the table, so we may as well use the initial one. So that's 70 kilopascals times my initial volume 174, and it's equal to my pressure, 300 kilopascals, my second pressure, multiplied by my volume, which is what we're trying to find. Okay, now you might ask, how come I'm so happily putting in things that are the wrong units here? With this formula, you can use any units so long as they are the same on the left and on the right. So if I've got kilopascals on the left, I have kilopascals on the right. If I have cubic decimeters on the left, I have cubic decimeters on the right. Just so long as you work out your answer, and your correct answer for your unit is going to be the unit that is in the question. So don't put the wrong unit. Remember, wrong unit, no mark. So if you whip out your calculator, I've got something like 40.6. This will be cubic decimeters because it's the volume, and this is what we measured the volume in. So this, I do believe, is your final answer here. Okay, when the volume of the gas is measured at 300 kilopascals, it's 44 cubic decimeters. Explain why the measured volume differs from the volume calculated in question 4.4. Okay, the gas is not an ideal gas is what this is basically referring to. So what's happened? At high pressures, real gases deviate from ideal gas behavior. Why do real gases deviate? Because the particles have forces of repulsion between them. Yes? Okay. Which temperature condition will cause a gas to deviate from ideal behavior? Right, only high or low. It will be at low temperatures. Explain your answer to question 4.6. Okay, what happens at low temperatures? At low temperatures, the gas particles may start to liquefy. Okay, they will not behave as an ideal gas. An ideal gas due to the intermolecular forces between the particles. Calculate the number of moles of gas in the container at the initial pressure and volume. Okay, so the formula we have that puts moles of gas in is PV equals nRT. Okay, we're trying to find N, we know R. So what do we need to do here to work out PV equals nRT? We need to turn this 20 into Kelvin. Remember, we're going to add 273 onto it to turn this into Kelvin. So the T equals 20 plus 273, which equals 293 Kelvin. We need to change our pressure. It says at the initial pressure and volume, that's 70 kilopascals. So we're going to make 70 kilopascals is 70,000 pascals. And my volume was cubic decimeters, 174. So 174 cubic decimeters needs to be in cubic meters because SI units in this formula. So this is 174 times 10 to the negative 3, because remember a cubic decimeter is smaller than a cubic meter. Okay, so let's substitute in here now that we've found these. 70,000 and the volume is 174 times 10 to the negative 3. That's my volume. Okay, equals N, which is what we're trying to find, times R is 8,34, yes? What's R? R 8,31. not 8,34, 8,31 times my temperature in Kelvin, which was 293. So let's do some calculation here. Okay, 8,31 something looks wrong here. Sheesh, my calculator and me. Oh, I'm looking on the wrong side of the equation. That doesn't help. 70,000 times 10 to the negative 3 divided by 1. I've got 5,002. So I'm going to say N equals 5 moles. And that there should be my final answer. There should be 5 moles of gas in this reaction.